Hello, this video is going to be on factoring, so it's going to be a mixture, a tutti frutti of different factoring methods, right? So be ready. Here we go. We have z plus 2 squared minus 5 times z plus 2. So the first thing you want to realize is that the base of this exponent is exactly the same thing as what I have here. So you want to almost think about those as being, for example, x squared minus 5x. Imagine my x here is replaced by z plus 2, right? That would then be x squared minus 5 times x. If you would have that and you needed to factor this, what do both of those terms have in common? It would be an x, right? So you would factor out an x. And then x squared divided by x would be x, and then negative 5x divided by x would be negative 5. So that's what you would have. Well, that's what you're doing here, except this here is not an x. What do those two terms have in common? A z plus 2. So you're going to factor out a z plus 2. And once you factor that out, what's left over? Well, you had a z plus 2 squared, you took one z plus 2 out, so there is another one left, right, because it was squared. So we have a z plus 2, and then you took that factor out, that z plus 2, so what's left over will just be negative 5, so it will be minus 5. And now that can be simplified, right, because positive 2, negative 5 goes to negative 3, so we have a z plus 2 times z minus 3. So that's how this would factor right there. All right, so number one done. Now let's look at number two. So number two, we really have three terms, right? A term is always anything that's typed together by multiplication or division, right? So separated by pluses and minuses. So this is one term, this is one term, and that's one term, right? Separated by pluses and minuses. What do those three terms have in common? Well, they all have a factor of 7, right? Because this is a negative 7. That's 7 times 2, and that's 7 times 3. So really, I could say a factor of negative 7. So I'm going to divide all of those by negative 7. Meaning I'm going to bring a negative 7 to the front. What else do they have in common? Well, I have an x to the fourth, x, and x, so at least one x everywhere. So I'm going to factor out an x, so bring that to the front. And what else do they have in common? I have a y squared, y cubed, y to the fourth. So at the least a y squared. So you always go with the least, right? Not the most when you're factoring. At the least a y squared. So you're going to factor a y squared out. Okay, so now what will be left over? Well, if you do negative 7 divided by negative 7, those will cancel, so no more 7 left. X to the fourth divided by x becomes x cubed, and then y squared divided by y squared, no more y, that goes to a 1, right, so times 1. Then we have a negative, so positive 14 divided by negative 7 becomes negative 2. And then x divided by x is a 1, so that can cancel to 1. Y cubed divided by y squared, that becomes just a y to the first power. Then we have a positive 21 divided by negative 7, that goes to a negative 3, so minus 3. And then we have x divided by x, that goes to 1. And then y to the fourth divided by y squared goes to a y squared. And now when you're looking at this, this is in simplest form, right? So that will be your factored term. And this is not factorable anymore, so we're going to stop right there. All right, number three. Number three is your classical quadratic, right? So we have a 3x squared minus 16x plus 5. When you have a leading coefficient that's not a 1, you're going to take the first and the last and multiply them. So we have 3 times 5. That's going to give me a 15. So on the side, I'm going to ask myself, what can I multiply to give me a 15, but add up to give me that middle term here? So I want to multiply to give me that 15, but add up to give me a negative 16. Well, if I do add up to a negative 16 multiplied to a positive 15. That would have to be a negative 1 and a negative 15, right? Negative 1 times negative 15 will be a positive 15, and a negative 1 minus 15 will be negative 16 when I add. So those are the two I want to use to replace my negative 16. So keep the first term, 3x squared. We're doing grouping here. Replace negative 16 by negative 1x and negative 15x. Right? We're just replacing that negative 16 with those two, and then keep your 5. Why did we do that? Because now we have 4 terms, and so we can go 2 by 2, see what we can factor out from them. What can we factor out from 3x squared and negative 1x? Well, we can factor out an x, so let's take an x out. What will be left over? So 3x squared divided by x will just be 3x, and then negative 1x divided by x will be minus 1. What can we factor out from negative 15x plus 5? Well, we can factor out a negative 5, and so what will be left over? Negative 15x divided by negative 5 will be positive 3x. Positive 5 divided by negative 5 will be a negative 1. Okay, so now what do those two terms have in common? Well, they both have a 3x minus 1 factor, right? 3x minus 1, 3x minus 1, so we're going to factor that out. And once you factor out 3x minus 1, here you're left with x, and here you're left with minus 5. And that will be your factored form. So that's the grouping method here. And so now we are looking here, we have a 2 times a plus b squared plus 5 times a plus b minus 3. So it is the same scenario as up here, except we have 3 terms. So you want to think about that as almost being like 2x squared plus 5x, minus 3, right? Kind of the same scenario. What would you do here? Well, what can you multiply? So you could do the grouping method again, right? 2 times negative 3, so that would be a negative 6. So what can you multiply to give you negative 6? Add up to give you a positive 5. And that would be negative 1 and negative... Oh, no. That wouldn't work, would it now? Would not work. It would be... I need to multiply to give me negative 6, add up to give me a 5. So that should be negative... Yeah, it would have to be. It would have to be negative 1 and positive 6, right? Negative 1 times 6 is negative 6, and negative 1 plus 6 is a positive 5. Oh, it took me a minute there, didn't it? So I would replace my 5x by negative 1x and plus 6x. So 2x squared minus 1x plus 6x minus 3. Except all of those x's are really not x, they're a plus b. So now let's translate that here. So we will have a 2 times not an x squared but an a plus b quantity squared minus 1 not an x but a plus b, and then plus 6 not an x but an a plus b, and then minus 3. Okay, what do those two have in common? Well, they both have at least an a plus b, so I'm going to take a plus b out. What's left over will be 2 times a plus b minus 1. And what do those two have in common? Well, they don't have an a plus b in common, but they at least have a 3 in common, so I take out a 3, so plus 3. What will be left over here will be 2 times a plus b, and then 3 divided by negative 3 divided by 3 will be minus 1. Okay? So we're going to keep simplifying here, right? So we have an a plus b Okay, this here and that is the same, so we're going to simplify that inside in a minute, but that's the same, so we're going to factor that out. 2 times a plus b minus 1, so all of that, so that will cancel here and there, and then what will be left over will be a plus b plus 3. So a plus b plus 3. Okay, now let's simplify here. We can distribute that 2, so we have a 2a plus 2b minus 1, and then multiplied by a plus b plus 3. Now that doesn't look very simple, but that's your factored form right there. Whew! All right. Number 5. When I'm looking at that, I see a subtraction of 2 terms, and both of those terms are perfect square, right? 9a squared in a square root becomes 3a, and 16 becomes 4. So those are 2 perfect squares. So when I see a difference of perfect square, I think conjugates. And so those are actually going to become the 2 conjugates. Conjugate means you have the same thing except with an addition and a subtraction, but the terms themselves are the same. So it will be a 3a and a 4, and a 3a and a 4. So it becomes 3a plus 4 and 3a minus 4. Those are the 2 conjugates. That's when you have a difference of perfect square. Number 6 is not a difference of perfect square, but it's a sum of perfect cube this time, because 27 is 3 cubed. That's obviously cubed, and that's obviously cubed. So we have a sum of perfect cubed. So that's another identity that you want to remember and review if you don't remember it. So that's going to go to, when you have a cubed plus b cubed, that will be the same as a plus b, a squared minus ab plus b squared. So that's the identity I'm using, right? I'm going to just put that underneath here so you recall. So what I want is, what is the cube root of 27x cubed, right? Cube root of a cubed was a. I want the cube root of that. So that's going to be 3x. And then the cube root of y cubed is just y, so plus y. Once I have my binomial here, right, I'm now going to switch to my trinomial, and my first term in the trinomial is whatever I had here, I'm going to square that. So this here is going to become squared, so 9x squared. Then my middle term of the trinomial is whatever I had here, I just multiply them with each other, but I keep a subtraction between them, so subtraction, and then multiply them, so that will be 3xy. And then the last term in my trinomial is whatever I had here, square it with an addition. So that becomes y squared. And that is my sum of perfect cubed identity. Oh, well, I didn't mean to do that, but that's still a sum of perfect cubed, right? So that will be the same identity up here. So that's a 1 plus the cube root of 1,000 is 10, so we have 10y. And then it will be this one squared is still just a 1. Subtraction, right? And then multiply them with each other. So 1 times 10y is just 10y. And then the second one squared, so plus 10y squared, which is 100y squared. Okay. Alright, so now we have a quartic, but it's a quartic that's going to behave like a quadratic because we have even powers only. So what you want to think about is, what would you do if this would be x squared minus 2x minus 8? Well, there is no number in the front here, so what can you multiply to give you a negative 8, but add up to give you negative 2? Well, it looks like we could have 4 times 2, and if I make that a negative 4 times a positive 2, that will be negative 8, and when I add those two, I will get my negative 2. So that technically would factor to an x minus 4 and an x plus 2, because there is no number in the front, right? So I can go ahead and do that. but I did not start with an x, I started with an x to the, sorry, I didn't start with an x squared, I started with an x to the fourth. So all of that here is going to be changed and it was minus 4 and then plus 2, except that when I would multiply those two I need to go back to an x to the 4, so that has to be an x squared instead. Okay, well, we have a difference of perfect square here, so that can be factored one more time, right? So this can be factored again as x plus 2, the conjugates, and x minus 2, and then this one is going to stay x squared plus 2. We could factor that within the set of complex numbers, but within the set of real numbers, this is going to be what we call a prime quadratic for real numbers. All right, we have 4 terms here, and when you see 4 terms, your first thought should go to grouping. Can you group that? Well, look, you have 2 terms and 2 terms, and you're going to look, what do those 2 terms have in common? Well, they both have a 9 and at least an x squared, so factor out a 9x squared. And if you divide 18 by 9, you're left with 2. Divide x cubed by x squared, you're left with x. Then divide 9x squared by 9x squared would just be a 1. What do those two have in common? Well, nothing but a 1, so factor out a 1. And so that's 2x plus 1. Now we're going to say, okay, well, what do those two terms have in common? Well, they both have a 2x plus 1, so factor that out. Then what will be left over, right? So if you factor that out and that, you would have a 9x squared plus 1 left over. 9x squared plus 1. And again, within the set of real numbers, this will be as far as we can factor. If we would factor within the set of complex numbers, then this could be broken again with the conjugates, right? So just as an example, I'm going to show you what I mean by that. This could be broken again, so that will be 2x plus 1. And then that will become 3x plus 1i and 3x minus 1i. So that's if I want to do that within the set of complex numbers, right? So for complex numbers. And this is if we're in the real number set. Okay? X to the 5 over 2 minus x to the 1/2. So this is when we have fractional exponent. I thought it was a good idea to look at one example at least. So we want to see what do they have in common. Well, they both at least have an x to the 1/2, right? So we're going to factor out an x to the 1/2. Factoring is a division. So really what I mean by saying factoring out is I need to divide both of those by an x to the 1/2. Now, I didn't write that down anywhere above, but just here, for the sake of showing you what's going on, I'm going to write that down. So we're factoring an x to the 1/2 out, and so what's left over? Well, factoring is a division, so we're dividing that. And when we divide, we subtract the exponent, right? When we divide the same bases, we subtract the exponent. So what is 5/2 minus 1/2? Well, on the side here, we're going to write it down. 5/2 minus 1/2, right? That will be, they already have common denominator, so that's kind of cool. 5 minus 1 is a 4, so that's 4 over 2, which just simplifies to 2. So this here becomes an x squared. And then we have a 1/2 and a 1/2. So x to the 1/2 divided by x to the 1/2, that's just divided by itself, so that becomes a 1. So now I have that. Well, this is a difference of perfect square, so that can be broken and factored again, right? So we have the x to the 1/2 that we had here, and then that changes into x plus 1 and x minus 1. And then that will be our finished product. All right, that's a whole bunch of different factoring methods. And if you don't remember all of them, don't panic. Review as much as you can though, okay? Practice all of those.